So this is going to be a 15th video. In this video, which is very in the previous videos I have told about very introductory things. So this video is going to be a very important. So in this video I'm going to tell you about the addressing modes and what is move and what is R and what is A and what is B. So in this, the move is nothing but an instruction used to transfer a data from one place to another. In this language, there is no case sensitivity. You can write either move in the capital or you can write move in the small. Both are okay in this assembly language. So this assembly language is used for this move instruction is used for transfer of data from one place to another, like from memory to memory or register to register. It can be used for that things. So this is a very important instruction known as move. And next thing, the R. And one same thing, that R can be written as a small or big. So this R is the general purpose register. So it is a general purpose register R. So there are many registers like R0, R1, R2, R3, R4, so on it will go. In the previous video I have told you about the banks. In the previous video I have told you about the banks. So the next one is the accumulator A, and there is one more special purpose register known as B. So A can be written as either accumulator in the capital or B can also be written in the capital. So the next thing I'm going to tell you about the addressing modes. So these are the important registers for now. There are many other registers which are special registers known as PSW, TMOD register. There are many other registers. So I'm going to tell you about them in the future. So let us go for the addressing modes. So the first addressing mode is immediate addressing mode. So what is the immediate addressing mode? So I have told you already what is a move instruction. So here move instruction is typed has now MOVE. Then now I'm going to tell you about the immediate addressing mode. So I'm going to take one register known as R0, comma, and I'm going to give one value as hash 25H. So what this instruction does is, so in this instruction move, I have told you it is used for transfer of data from one place to another. But I have written here R0 comma hash 25H. Either data must be going from 25H to R0 or R0 to 25H. So this thing you may be understanding it. Here the data is going from 25H to R0. Actually the data is not going, the value 25H is going, because it is an immediate addressing mode. So here the immediately value 25H is going into R0. So here one more thing, whatever first is written is destination. Means whatever data has to be given, it is given to the first whatever the thing is written, like register. So R0 is going to be a destination for 25H. What is the 25H? 25H is immediate value. Immediate value. So 25H is going to be immediate value. This 25H is directly given to R0. Means whenever you use a move instruction, first operand is going to be a destination and second operand is going to be a source. So it is going to be a source. So this is a source and this is an operand. Okay. So let us run this program. And here one more thing, the comment is written in this format. So semicolon is used for the writing the comment. And one more thing, there is no semicolon for the end of the statement. There is a semicolon in the C programming, but here it is not there. So let us run this program and we will see what it will give as an output. So to run the program, you must, I already told how to add the file in this source group and all in the previous video. If you want to see it, you can see it. So just click on this file, then build target. So it is builded. There is no errors. Then go for debug, then this one, and then OK. Then after, again go for debug and run. You may be seeing R0 value is not 25. So this program did one thing, that this 25 is immediately given to R0. So this is known as immediate addressing mode. So now next we will go for the next addressing mode. So let us comment it first, this one, then we will go for the next addressing mode. So next addressing mode is going to be, register addressing. Here what happens, the value of register is directly given to the another register. So let us do it, another register, but there is one restriction for it. I will tell you restriction by showing it. So we will write one more time move. We will use this only, this line we can use it again. So we will use this line. Let us use this line back. So now I have given R0 has a 25h. Now let us move this R0 value to the register R1. R1 is what? Destination. So source is going to be R0. So R0 is having a 25h value. I am going to move that data into R1. So I am moving basically 25h to R1 from R0. R0 is what? Source. R1 is destination. So let us run this program. We will see what does it happens. So here coming an error, that is invalid registers. So this thing you must keep it in mind. I am showing this because it is very important. Here you can't use the two general purpose register for any instruction. Two general purpose registers cannot be used, but you can use a special type of registers. A, B, A, B are two special registers. I'm going to show you that instruction too. So let us comment out this one. So R0 is holding a 25h value. Now let us move this 25h value into A. So here the source is going to be what? No, the first we should decide the destination. Destination is going to be what? A, accumulator. And what is going to be a source? That is R0. So now let us run this program and see what does it give. So build target. So there are zero errors. Then start or stop debug. Okay. Then we will run it. So you may be seeing R0 is holding a 25 value. This is the registers. This is one of the important thing I forgot to told it. See. So this is having R0 is having a 25 value and A is also having a 25 value. So this is a register bar which is having all the registers which are present in the 8051 microcontroller. So you may be seeing there R0 to R7 are the register, and downside are the special registers. You may be seeing A, B, SP, SP max, PCS. There are many other registers, PSW. So PSW is having this format of structure. There is a structure of PSW also. So now let us go to the next addressing mode. So this addressing mode was known as register addressing mode. You are using the two register to address it. Now let us go for a direct addressing. So for direct addressing, let us comment it first this two. So I have commented this two. Now let us go for the direct addressing mode. Here what I am going to do is I am going to take R0 one register and I am going to load a value known as 40H. So you may be thinking what is hash is used and when not hash has been used. So here if hash is not used, it takes the memory value, that is whatever 40h is holding, it is going to take that value. So let us do one more thing, that is let us load the value in the memory 40h. So to load the value in the memory 40h, I am going to write one more instruction. So here the destination is going to be what? The memory 40h. And what is the source is going to be? I am going to give a value as the source. So I'm giving a value as a source is hash 20h. So now 40h is going to store a value known as 20h. So that 20h is going to be coming in 40h. that 40h is holding a value of 20h. So the R0 is going to be a value of 20h. So what does it doing means, I'm going to write a comment here, that is 40h memory is having what value, 20h. So now I am moving 40h addresses value, that is 20h. So now R0 is going to hold what value, that is 20h. So it is going to grab the value from the address. So if we don't write a hash, it is going to grab the value from whatever the 40h address is going to hold. So let us run this program and see what does it give. So I have run. So it is showing 0 errors. So let us run this. So okay. Now let us run. See, R0 is having holding the value of 20. You may be seeing this. So this is known as direct addressing mode. So now let us go for the next one, which is known as indirect addressing mode. So this indirect addressing mode, let us try this one. So in indirect addressing mode, let us comment this two also. For comment there is a semicolon. Keep it in mind, which is also important. So now let us go for the indirect addressing mode. So I will make R0 holding the value of 40h, means whatever the address 40h is holding, it is present in R0 now. Then I'm going to make 40h having the value of, again 20 only we will make. I could have taken that only, but it's okay. Let us be, I have written it. So now I'm going to make what? I'm going to make a destination as A, and I'm going to take the value from R0. So I will take the value from R0. So here is a one more thing to be used, at. So now I'm going to use the at operator. So whatever at the address of R0 it is having, that value is given to the A. So let us try it, but sometimes it does not run. So let us see if it is running or no now. So at R0. So let me see what does the output I will get. I don't know what does the output it gets, because I also not tried it. I'm trying it first time. So let me run it. So it's not giving any updated value. Let me see. So now this value 20, it is having, okay, I have made a mistake here. So hash 20h. So let us inbuild it. Then we will run. So this is going to be run, debug, run. So R0 is updated, but A is not updated. Let me see why the A is not updated, which is also important. So now 40h is holding, 40h memory is holding the value of 20h. Then that 20h is given to R0. R0 is having the value of 20h, but address of R0 is not holding the value of 20h. Why? Because R0 is having the value of 20h. So R0 is going to do the thing is, at R0. At R0 means whatever the R0 is having the value, that is 20h. So whatever the 20h memory is holding, that value is going to be stored in the A. I have not updated the 20h value. So there is a one more thing to do it here. That is, here what happened means, I will write the comments about it. So now 40h is holding what value? 20h. 20h. And R0 is having holding what value? It is also holding a 20h value itself, because I have made it, because from the address 40h I have to 20h. So the R0 is going to hold what value? That is 20h. Then what is this at operation do? At means address of R0 means address of R0 is holding what value. So it will go for the R0 and check the value of 20, whatever the value it is holding, and whatever that address is holding value, that value is going to be updated in A. So let us write it. So at R0 is equal to 20h, but 20h is what now? I have not updated any value in it, so it is 0. So there is no value updated to A. It is going to remain as a 0. I think you might be getting confused what this instruction did, but you will get it to know in the future because I'm going to make some programs on that. You will understand it. So how to update this value of R0, you may be thinking. It is having the value of 20h. You must go for the address 20h and update the value of 20h. Then A is going to hold on value. There is also how to update is, let us debug this. First I will build it, then I will debug it. So for updating the memory of 20h, here is a memory window. You must type here 20h and enter, and you must update the value here. So if I update here 2, but this thing does not work sometimes, we will try what does it do. So I updated the value of 20h as 2. So now let us debug it, run it. See, still the A value is not updated. So this memory window sometimes does not work properly. So you just keep it in a mind. This addressing mode just do one thing, that is just grab the whatever the address of R0 is holding. So that is the at R0 instruction is used for. So this is indirect addressing mode. So totally I have told you about the 4 addressing modes, that is immediate addressing, register addressing, direct addressing, indirect addressing. I feel you might be feeling the bit confusion about this addressing mode. This will be more cleared in the future videos. So today that's it for today. Thank you.